Hello everyone, I'm excited to share with you our recent work on crowd hat boosting detection and crowd analysis via underutilized output features. In the task of crowd analysis, traditional detection-based methods have been viewed unfavorably due to their poor performance. However, we argue that these methods offer crucial information that is often ignored. For instance, in dense crowds, bounding boxes tend to be smaller with lower confidence scores due to occlusion, while sparse crowds tend to produce boxes with higher confidence scores. To leverage these underutilized features, we propose CrowdHat, a plug-and-play module that can be easily integrated with existing detection models. Our approach uses a mixed 2D, 1D compression technique and region-adaptive NMS thresholds to address the major limitations of detection-based methods. And we evaluated our method on various crowd analysis tasks and achieved state-of-the-art performance on several benchmark datasets. We believe that CrowdHat has great potential for practical applications in real-world scenarios. Thank you for your attention. Next, we will provide a detailed presentation of our work. First, we introduce a mixed 2D, 1D compression technique to refine output features from detection-based methods for crowd analysis tasks. The principle of 2D compression is to divide the output features into patches of equal size, and then sum up the output features within each patch to obtain a corresponding element. These elements are combined into a matrix M, where each element represents the sum of all output features within the corresponding patch. This approach effectively captures spatial information of crowd density distribution and reduces computational complexity by compressing high-dimensional feature vectors into low-dimensional representations. And the principle of 1D compression is to normalize the confidence score and area size values to a range of 0 to 1. Divide this range into discrete intervals and calculate the number of values that fall into each interval to form a histogram. The ITH value of the histogram represents the number of values that fall into the ITH interval. This approach effectively captures numerical information of crowd density distribution and reduces computational complexity by compressing high-dimensional feature vectors into low-dimensional representations. The CrowdHat module includes several convolutional layers with ReLU activation and max pooling, which transform the compressed features into global and local feature vectors. Specifically, 2D convolutions are used to further encode the spatial information from the compressed 2D matrices, while 1D convolutions are used for the numerical distribution information from the compressed 1D distribution vectors. After global average pooling, both features are concatenated to form the global feature vector FG, which is used to regress the crowd count over the input image. Besides, we divide the 2D compressed matrices into KXK patches and process them with 2D convolutional layers to obtain KXK local features. And then, global feature is fused with each local feature and regress the corresponding NMS threshold within the patch. It is worth noting that NMS process is non-differentiable, and we obtain the NMS thresholds by linear search, and directly regress these thresholds. After that, we propose a decoupled n-align paradigm to decoupling the crowd count prediction from the detection and localization results, and then aligning them to improve accuracy. Specifically, we use the predicted count to guide the bounding box selection to achieve better performance in crowd analysis tasks. Our CrowdHat module can be easily added on various one-stage and two-stage detection methods, and it can significantly enhance the crowd analysis performances on crowd commuting, crowd localization, and crowd detection. Our CrowdHat module is lightweight. After adding our module, there was no significant increase in model size or inference time, making it easily to be adapted to different methods. Our work demonstrates that using detection outputs properly is crucial for improving the performance of crowd analysis tasks. Now we are working on implementing the CrowdHat module in more methods, and our code will be coming soon. Thanks for your attention again.